So this froth flotation process is mainly adopted for sulfide containing ores, like copper sulfide or zinc blende and so on. Now, these sulfide ores are first mechanically crushed, and then they are they are uh, they are transferred to a container containing water. So there are three aspects in fact four, for this froth flotation process. The first, I think I've mentioned earlier, but the first are the frothers. So these frothers are the ones which helps to make the froth. So these are like it can be a pine oil, camphor oil, and some other even organic compounds also, which when you add to the vessel, suppose here's the vessel containing the ore. I'm not good in drawing, so please excuse me. So, if the ores, let's say the ores are inside the tank containing water, so we add these frothers, pine oil or camphor oil, and then usually they stir the whole mixture in order to generate the froth. Because the technique here is that since these metals we are assuming it to be positively charged in solution, so we are taking advantage of that for extraction purpose. And once you keep on stirring, the froth starts to emerge, the bubbles, the foam. So what they do is the froths are transferred to another tank, another container, flows out, and then it is dried, because the froths eventually will dry out, and then we collect the ores. That's what we do. But in between, again, the froths that are being generated are not that. If they are not that stable, we add again froth stabilizers. So what is the purpose of these this froth stabilizers? So it increases the life period, of the froth. And usually these are again some other organic compounds like aniline or cresol. So the purpose of me explaining this way is because usually not only in our exams or tests, these things are usually asked in competitive exams. So I'm trying to break it down. So these are the froth stabilizers, which increases the life period of the froth that are being generated. Suppose these are the froths, foams that are being formed due to subjection of mechanical input like magnetic stir, or you can say a rudder fitted to a motor, and so on. They do it. So that's how we generate or extend. We generate and extend the life period of the froth. Now after that, what we do is we add some surfactants or collectors. Surfactants, or they are called as collectors. And these are like sodium ethyl xanthate or sodium lauryl sulfate. So what its purpose is to help in collection of the froth. It helps in collection of froth, collection of froth, or absorption, absorption of the ore, absorption of the ore particles on the surface of the froth, on the surface of the froth. So suppose let's say this sodium ethyl xanthate, yeah, sodium ethyl xanthate. So see, this these are these are surfactants. This is also another long chain surfactant. Like they act as micelles. See, these are polar charged. This end is charged, and this end is non-polar. So we can say these are hydrophobic, hydrophobic, and these are hydrophilic. Now, this end, we know that suppose copper or zinc, they are positively charged. These central metal ions, the d block elements, are taken to be positively charged. So this gets attached to these metals, and then within the froth, they are being attracted, and so this job, the surfactants or the collector's job, is to adhere to the metal, to the ore, and then so that this end, hydrophobic end, now repels with water, so it can go up with the froth, so that it comes down, so we can extract it, we can take it out from the mixture of from the mixture from the water. That's the purpose of this surfactants or collectors. And then after collecting, we have if the metals are again a mixture, if the ores are a mixture, then what we do is we add depressant or activating agent, depressant, or call us the activating agents. And these are sodium cyanide and copper sulfate. So this, what its purpose is to decrease or increase flotation of ore particles. Flotation of ore particles. So its job, either sodium cyanide or copper sulfate, its job is to uh, release the suppose uh, suppose these two are present together, then this sodium cyanide can bond or can complex with one of it, both of it, and then later on by adding copper sulfate, one will be released. Suppose zinc sulfate may be released, and then it goes back into the solution again. That's how it's being done in flotation process. So this table, if you can go through this table, so you'll be able to write it properly. I mean, even in the exam also, you can summarize this way for study. And then you can read some of the steps so that so next let's move on to leaching of the bauxite ore. Leaching of the bauxite ore. These are usually asked in the exam also, so you be attentive. So we know that bauxite is the principal ore of aluminum. Is the principal ore of aluminum. So we can extract profitably aluminum from bauxite ore, and this aluminum is a very useful metal, of course, because one thing, it is cheap, and then uh, it is we can make a lot of alloys with aluminum, so it's a very useful ore for our daily purpose. Now, but this bauxite contains aluminum oxide as the chief composition. Then we have silica or silica dioxide, sand, and then we have ferric oxide and titanium oxide too in small amounts. So for extracting aluminum, we have to remove this impurities. We call it impurities. Suppose, as I mentioned, suppose this is 80%. This is 5. Maybe this is 10, and this is 5%. So the larger amount, the larger percentage is we extract for our purpose, and the rest, even if it is present, we consider it to be as impurities. So step 1. In the first step, digestion of bauxite ore in some alkaline solution like sodium hydroxide solution. So aluminum oxide and or these impurities, along with the impurities, are dissolved in sodium hydroxide solution. Because ferric oxide and titanium oxide, they remain insoluble. They remain insoluble in this alkaline solution, so which can be removed by filtration. Removed by filtration. So when you treat aluminum trioxide with sodium hydroxide in presence of water, because it's an alkaline solution, and then heat it to at a little bit of pressure, then we get sodium aluminate. So this is our sodium aluminate, and this is in the aqueous state. And even our silica dioxide reacts with sodium hydroxide to give us sodium silicate. Sodium silicate plus a little bit of water. In the second step, neutralization of sodium aluminate with carbon dioxide. So in this step, our sodium aluminate that we have obtained in the first step, sodium aluminate is carbon dioxide, we get aluminum trioxide, trihydrate. Plus sodium bicarbonate. We get sodium bicarbonate in the solution. And then in the third step, what we do is we heat the aluminum trioxide that we have obtained, trihydrate, to get aluminum trioxide. In 70 Kelvin, and then we get aluminum trioxide as water is removed in the form of water vapor. This is called water of crystallization. This helps to crystallize or balance the charges of this aluminum trioxide and make it as a crystal. So these are the few steps that we usually do for or during leaching of bauxite ore. And then and then but this aluminum trioxide has oxygen. So what we do is we let it we perform all Herold's process to obtain the aluminum, and that is what we do in whole Herold's process is electrolysis of the compound. Let me check if I all Herold's process. Yes, I have. So this is our whole Herold's process. So what we do is we the metal, there is a metal doom iron iron dome, and then it's lined with graphite or carbon, and then we have another we have carbon graphite electrodes. So this whole thing acts as a electrolytic cell. So in here we introduce the aluminum trioxide, and then we add sodium aluminum trifluoride as the electrolyte. I hope you know what is electrolyte, because this solution won't be conducting electricity, but by the addition of this electrolyte, this sodium aluminum fluoride will this this will break up into sodium plus the fluoride will be negative, so positive and negative, so that will act as the charge carrier. So this graphite, these carbons, they act as the cathode lining, and then the metal dome will act as the anode. So by supplying current and due to the presence of the electrolyte, this molten aluminum trioxide uh, will be the aluminum metal will be extracted profitably. In the cathode, the aluminum melts and then get 3 electrons within from the solution, from the electrolytes, and then it forms aluminum metal in the liquid state. And so the other things like the coke or carbon will be removed as carbon monoxide or carbon dioxide in the process. The whole process is summarized here: aluminum trioxide plus 3 carbon or coke, or this from this carbon lining. Then we get the aluminum metal, and then carbon dioxide will be removed as a gas. So that is our whole hero's process. I'll give a PDF of or a snapshot of this material so that you can read it. So these are some of the processes that are being employed in metallurgy. So even here also they have summarized the Byers method for extracting the aluminum trioxide. If it is clear enough. And then we have again another process, Kroll's process, for extracting of titanium from titanium halides like titanium chloride. So through Kroll's process, we can extract titanium, and then Mann's process is used for extraction of nickel from its ore. So much of the things are to be studied by you. So I'll try to provide this unit is especially like this unit is especially most of the things are, if you can read on your own also, you'll understand. But if you have any doubts you need to clear, you can ask me. See, another process, Van Argel process, it's for extracting very pure metals in small amounts like titanium, zirconium, or bismuth. So these are what we call as the rare earth metals. So for purifying, we we employ one arcal deep wire process. So I don't think this Sparks process is included for, but this Sparks process is again removal of impurities like lead from silver. These two are heavy metals. So and then they occur together in the ore. So for purifying silver, so we employ Parks process. So these are some of the things that we have to study. So I'll try to provide all the materials as much as I can, and then there are some references also given in your syllabus. So J.D. Lee is a good book. This one, Cotton and Wilkinson. This, if you can get the third edition, the third edition. Of course, it is out of print, so you can contact if you have friends or relatives living in Kolkata. So you can contact them. Like you can, because it may be available in the College Street in Kolkata. It has the world's it is the world's largest book depot. So you can collect it from there. This is a very good book, third edition, Advanced in Organic Chemistry, Cotton and Wilkinson, very good book. And this also for this Shiver and Atkins. Uh, or Peter Atkins is a good physical chemist. So this inorganic book that they have written, Shiver and Atkins, are somewhat towards a physical approach. So it's also another good book. So if you have these three, one, two, J.D. Lee, then I think, yeah, you're in good hands for this semester, for this particular chapter. So I think, yeah, I think we'll wind up there for today. Still uh, some more time left. If you have any questions, you can ask now. If you want any of the things that I've explained, you want to clarify, so you can ask me now. I hope all of you are listening, because if you are watching last night's football match, most of you will be in half-cooked state. So if you have any queries, you can ask now, or else let's wind up for today. So we'll start the next chapter from the next class, acids and bases. So I want you to go through, if you don't have any queries, if you don't have any questions, I want you to go through at least this preliminary concepts of Arrhenius, Roncesvalles, so that you'll be in a, you'll have a good grasp of the idea of what are acids and bases. This I think you might have said it in class 11 or 12, these acids and bases, about this concepts, Arrhenius concept, Roncesvalles concept. This Arrhenius concept is about the dissociation of proton. And Bronsted-Lowry concept is again transfer of protons. I think Lewis concept is more sound because this is the concept that is widely used for acids and bases, because here we invoke the concept of transfer of electrons. If if a species accepts or donates electrons, pair of electrons, we define it to be an acid or a base accordingly to the donation or accepting of electrons. All right, and then we'll move on to the HSAP principle, parts of acids and bases. So, yeah, if you have any of those books that I've mentioned, you can go through. It's even available in the internet, so you can go through and then well. So regarding Unit 1, I'll try to supply the materials as fast as possible. So Thursday, we have 3 classes for this 2.1 course. So the last period, we can have tests, online tests. I hope that is okay. All the questions would be MCQ. So the type of questions that I put forth is you need some thinking order skills for those. So I think that'll do for today. All right, thank you. We'll see you tomorrow.